This training mission follows the procedures described on the flight manual of the real aircraft, plus the checklist of the 476th Virtual Fighter Group, which adapted the same manual for use on the MiG-21 bis of DCS. For brevity, we will skip most of the steps of the interior inspection, only performing those that are absolutely necessary. The checklist includes the following sections. Before entering the cabin, interior inspection, prior to engine start, starting the engine, and after engine start. If the cockpit interior is too dark, you can activate the flashlight with right control plus L. Also, you can press spacebar to cut short long voiceovers, in case you are resuming the mission. When clicking on a switch, remember that a left click flips the switch down or back, while a right click flips the switch up or forward. Finally, if the noise from other air traffic becomes too loud to hear me clearly, you can close the canopy at any moment with right control plus C or by clicking on the highlighted canopy support bar. Press spacebar to begin. While the MiG-21 can be started just using its onboard batteries, these have a limited endurance and wouldn't give us enough time to go through every aircraft system in detail, so we will instead ask the ground crew to connect a ground electric power cart. Press the / key, or the PTT button on your HOTAS, to call up the DCS communications menu. Select F8, ground crew, F2, ground electric power, F1, on.
Chief, turn on the ground
Press
power.
spacebar once the ground crew has connected the external power.
Copy. Ground power is now on.
Set battery and ground power switch to on. This switch connects both aircraft batteries and the external DC power input to the electric system DC buses. The voltmeter should display 28 to 29 volts with the ground power unit running, while with just batteries it would show 24 to 25 volts. Remember that if the cockpit interior is too dark, you can activate the flashlight with right control plus L and move the light beam with the mouse. Set AC gen and ground power switch to on. The external AC power input is connected to the AC buses. Once the jet engine generator is producing AC power, it will be connected as well. Set DC gen switch to on. This switch has no effect at this point, but once the jet engine generator is producing DC power, it will be connected to the aircraft DC buses. PO750 start number 1 and 2 inverter switches, set both to on. The AC-DC inverters will provide electric power by converting available AC power into DC power. Battery heating, on. Even if it is a warm day, enable the heating for the batteries compartment. Master warning light, acknowledge. Once the battery and ground power switch is on, the centralized dangerous conditions warning system, source, master warning indicator button light starts blinking. Depress it to turn it off. A DCS bug forces you to press this button once for each system that generated a caution, while on the real aircraft you would press it just once. As it is still quite dark at this hour and now we have electric power, let's adjust the interior lighting instead of keep using the flashlight. All cockpit light controls are located on the right side panels, 4 knobs in total. The highlighted knob adjusts the front panel instrument's backlight illumination. Turn it as desired and then press spacebar to continue. The next knob lets you adjust the console label's backlight. Turn it as desired. The highlighted knob adjusts the cockpit red floodlights, which will illuminate the general cockpit area with a red light suitable for night flights. Finally, the highlighted knob controls white lights that illuminate the right vertical panel, for use during the startup procedure at night. White light is not suitable for night flights, so after you start up the engine and turn on the red lights, you should turn this light off. Rotate it as desired and then press spacebar to continue. The MiG-21 has several warning panels illuminated with colored lamps, red, yellow, and green. Each panel has a knob to set its lamp's intensity in 2 levels, day or night. The knob can also be pressed to check that. Press spacebar if you want to learn this part of the procedure, or press backspace to skip it. All circuit breakers and switches on the right side electric panel should be off, down or back. These switches provide electric power to the individual instruments and devices of the aircraft. Check that the oxygen pressure in the pilot's oxygen level gauge is within the range of 130 to 150 kilograms per squared centimeter. Check the landing gear lever. it should be on neutral position and latched. Check pressure on both the main and emergency air systems, 110 to 130 kilograms per squared centimeter. The aircraft pneumatic system has two subsystems, main and emergency. The main system is used for wheel braking, jettisoning the JATO, jet-assisted takeoff units, sealing the cabin canopy, controlling the drag chute nacelle doors and jettisoning the drag chute, as well as for controlling the anti-icing system, liquid cooling system and pressurizing the radar units. The emergency system is intended for emergency extension of the landing gear and emergency wheel braking. The compressed air used in the system is stored in air bottles. Their pressure is checked on a 2-pointer pressure gauge on the cabin right console. Check that JATO Start Sys and JATO Jet Sys switches are off. To shorten takeoff distance, the MiG-21 can be equipped with JATO rockets for jet-assisted takeoff. The JATO provides a large thrust increase for about 7 seconds. JATO is synonymous with RATO, rocket-assisted takeoff, and the equivalent Russian acronym is SPRD. They employ the same fuselage support as the countermeasures pods, so they can't be fitted simultaneously. To enable the use of the JATO rockets, when fitted, turn on these two switches. Start your takeoff run normally, at full afterburner. When your speed reaches about 120 to 150 km per hour, the JATO rockets will engage automatically. RATO Start and RATO Drop buttons, guarded. The RATO Start button, under a black cover on the front instruments panel, allows you to engage the rockets manually, however this is not recommended. The red guarded button, beside the throttle, drops the JATO rockets after takeoff. You must press and hold it for 1 second. This is the same button used to drop countermeasures. Press spacebar to continue. Press spacebar if you want to perform the interior inspection procedure, or press life support panel. Check the following. On the IY7 panel, on the left console, the blue air dilution switch, 100% oxygen, should be in the mixed position, back. The red emergency oxygen and black helmet ventilation switches should be in the off position, back. Press spacebar to continue. Cockpit air conditioner selector switch, set to its auto position. Engine starter mode switch, set to normal start. The cold start position is used on the real aircraft to cold crank the engine, to drain fuel off the jet pipe after a failed start. This is not simulated on DCS. Press spacebar to continue. Engine upper panel, set the following. Auxiliary nozzle control switch, off. This is an emergency switch, to be used when the exhaust jet nozzle automatic control system fails. SPS switch, off. The SPS-141 is an electronics countermeasures pod that can be carried by the MiG-21 on its ventral station. This ECM pod is not designed to jam enemy aircraft radars, it is primarily designed to operate against Hawk SAMs. ARU-3VM mode switch, unlabeled, set to auto. The ARU is a device that controls the ratio between the flight stick pitch and the horizontal tail movement. The ARU is designed to operate in an automatic mode, but if needed, the pilot can switch it to manual mode. Press spacebar to continue. RSBN control panel, set. Set mode switch to RSBN, up. Select RSBN channels, for navigation, and for landing. For this mission select the RSBN station of Inche's Airbase, runway 22, number 12. Set the RSBN volume knob to its mid position. On flight, use the knob to adjust the volume of the identification Morse code received from the RSBN station. Press spacebar to continue. Engine lower panel, set the following. E-nozzle switch, set to auto, up. The anti-surge door on the engine exhaust is operated by a control system that can function either manually or automatically, as set with this switch. Cone automan switch, set to auto. The best position for the air intake cone depends on engine speed, airspeed, and flight altitude. As the RPM are reduced and or the airspeed is increased, the cone will extend, and vice versa. The air intake electro-hydraulic control system is provided with both automatic and manual control, selected with this switch. When set to its main position, the pilot can move the cone manually using the knob on the cone position indicator, to superimpose its wide and narrow pointers. Press spacebar to continue. Drop chute button, guarded. This button is used to release the landing parachute. Engine forward panel, check the following. Auto gear brake switch, set to on. This switch activates the anti-skid system for the main wheel brakes. The engine air start switch is in the off position, down, and locked. On DCS the lock is not simulated. AFB switch, on. The engine of the MiG-21 bis has a two-stage afterburner. This switch enables the first stage. Engine APU switch, on. The MiG has no APU in the Western sense. This is just a bad translation for engine start unit. This switch only arms the starter AC generator used for both engine start and power generation, after the engine is running. It is left on so that the engine can be restarted in flight if it flames out. Fire extinguisher switch, set to on. This switch enables the fire extinguisher on the engine bay. Throttle, confirm that the throttle lever is in the stop position, both on the sim and on your HOTAS. Fire extinguish button, check that it is guarded. Pressing this button will discharge the fire extinguisher bottles. Note that the system must have been previously enabled. Press spacebar to continue. Confirm that the taxi landing lamp selector switch is in the off position. Check the aileron booster switch is in the on position. The aircraft hydraulic system includes two self-contained systems, main and booster. The main hydraulic system powers the landing gear, wing flaps, air brakes, jet exhaust nozzle, air intake cone movement, engine derumble doors, and control of the electronic equipment bay cooling system. The booster hydraulic system ensures operation of the rudder and aileron boosters. This switch is only used in the event of an emergency, when because of some failure or damage the aileron's hydraulics are lost, so that the pilot can manually operate them by setting this switch to off. Press spacebar to continue. Confirm the AP pitch power switch is off. This autopilot switch is located on the right console and can be used to disengage the automatic flight control system pitch channel when the autopilot is functioning in the stabilization mode. The master mode air ground and weapon mode switches are set to positions required for the given flight mission. Master mode, for our configuration, set to air. Air-to-air missile mode. IR is for infrared guided missiles, NUT is a neutral position for no missiles. Set to SAR, semi-active radar homing, for our current radar guided missiles. The weapon selector knob should be adjusted as required for the given flight mission. For this mission, set it to 1, inner left pylon. Check that the RSBN Proceed Nav Landing switch is in the nav position. The RSBN has three modes of operation: navigation, nav, cloud penetration, and descent, proceed, and landing, LDG. The latter is equivalent to the Western ILS system. Confirm that the nose cone position dial pointers are in their 0 position. The white needle shows current position of the nose cone. When using manual control, the knob allows you to rotate the black-white needle to the desired position. The white needle will follow, indicating that the cone is moving to that position. Check that the outer inner beacon selector is set at outer. Check that the radio compass distance counter reads as required. Confirm that the emergency landing gear wheel braking handle is depressed and locked in that position. Check that the nose wheel brake switch is in its off vertical position. Confirm that the clock indicates the current time. On DCS it's automatically set at start. To set the time of day, stop the clock by rotating counterclockwise its right silver knob. Then right-click and hold its red knob, while turning the mouse wheel to set the desired time. Start the clock by rotating the right silver knob clockwise. Clicking the red knob activates the mission time on the small top dial, a second click stops it, and a third click will reset the mission time. Inside this dial is a status flag: small white square, mission time is running; larger white square, mission time is stopped; black, mission time is reset. The stopwatch is shown on the small lower dial, to a maximum lapse of 1 hour. It's controlled with the right knob on the same way as the mission time. Check that the red covers of the external store's emergency jettison buttons outboard and inboard are closed. Confirm that the red cover of the emergency launch missiles rockets button is closed. Check that the TAC drop switch is locked in the off position. This switch arms any bombs prior to their tactical release. Confirm that the radio altimeter's low altitude selector is set to off. Transponder panel, set. The SOD-57 is a civil transponder used by the ATC to more precisely determine the distance to our aircraft. Its use is not simulated on DCS. ATC switch, on. ATC mode knob, set to guidance, course. Wave switch, set as indicated by ATC, not used on DCS. Pitot selector, main. The MiG-21 has two pitot tubes to gather air pressure data, the main tube, located on a rod on the upper nose of the aircraft, and an emergency pitot installed on the upper right portion of the forward fuselage. Both pitot tubes can be electrically heated. Radar remote panel, set. This panel configures the operation of the RP-22 radar. Confirm that its switches are as follows. Radar switch, off. This switch powers the radar. On the standby central position, the radar refrigerant lasts for 2.5 hours. On the on position, the coolant will last for just 45 minutes. For now, the radar should be off. Low alt switch, off. This switch enables an electronic filter to remove ground clutter reflections from the radar display. Locked beam switch, off. This switch locks the radar beam along the longitudinal weapon axis, enabling distance measuring when you attack ground targets. Press spacebar to continue. The automatic radio compass, ARC, is the Russian equivalent of the Western Automatic Direction Finder, ADF, which gives a navigation bearing towards a ground non-directional beacon station, NDB. Set as follows, ARC mode switch, set to compass. The ARC could also be used as a voice radio station receiver, with no transmission abilities, by setting this switch to antenna, but has no practical use on DCS. ARC volume knob, turn fully clockwise. ARC sector knob, set to 1-2. The frequencies of the ARC ground stations that we can use are pre-programmed on the ARC receiver by our maintenance crew. They are grouped on 4 main geographical sectors, numbered 1 to 4, and each of them comprising 2 subsectors, 1 and 2. For our current DCS map, Sinai, only the 1-2 sector is pre-programmed at the moment. Channel, select 1 to 9. The ARC panel holds 9 preset NDB station frequencies, for each sector. For this mission, set it to 3, which is the nearest NDB station, at Al Salam. SPO-10 radar warning receiver, RWR, power switch, off. The RWR will show you the relative direction of radar emissions that reach your aircraft. It has 360 degrees azimuth coverage plus an elevation coverage of ±45 degrees. The button on the center of its display serves as a self-test, and the knob to its right adjusts the warning tone volume. You can click on the letters D or N to set the day or night mode of its lights. This device is completely automatized, so you don't need to interact with it during flight, apart from simply turning it on. Unlike the radar, it does not emit any signals, so it's safe to use it at any time. IFF emergency switch, off and guarded. The SRZ-02 IFF system installed on the real MiG-21 BIS permits the identification of friends and foes on radar contacts. This IFF system had 2 main operating modes, interrogate, Zapros, or respond, OTVET. On DCS it is not simulated. IFF self-destruct switch, off and guarded. To be used in case the aircraft was going to crash into enemy territory, as the IFF codes were secret. Not simulated. IFF code selector dial, as assigned. This dial allows the pilot to select the current IFF code among 12 available. Not simulated on DCS. Press spacebar, communication radio panel, set. The MiG-21 BIS simulated on DCS employs the R802G VHF-UHF radio. This radio has 20 preset channels, which can only be set via the mission editor. Select radio channel. For this mission, select channel 01, which is tuned to inches airbase air traffic control frequency. Volume knob, turn fully clockwise. Set mode switch to radio. Set the squelch switch to on. Set cone power switch, on. Barometric altimeter, set. This instrument measures barometric altitude up to 30,000 meters. The small needle points to an altitude in kilometers, while the big needle points to tens of meters. Adjust the atmospheric pressure knob to the one stated on the mission briefing. On DCS it is already set on mission start. Check the voltage and capacity of the aircraft batteries. We will skip the battery test for this mission, as we are currently using ground electric power. Connect external ground power. We already completed this step of the procedure earlier on this mission. Check that the stabilizer on green light comes on. This lamp indicates that the ARU horizontal tail movement control system is set up for low-speed tail movements, maximum movement. If this signal is on and you have an airspeed greater than 450 km per hour, then your ARU system is broken. ARU pitch ratio indicator, full left. The ARU gauge shows the current position of the ARU arm overimposed on a speed-altitude scale. The speed and altitude scales serve to provide a rough orientation whether the ARU system is functioning as expected. For example, the ARU should be at long arm, needle to leftmost, maximum horizontal tail deflection available, if the speed is 450 km per hour, and at short arm, needle to rightmost, partial horizontal tail deflection available, if the speed is 850. Reverse logic follows the altitude rules: the higher the altitude, the longer the arm. However, the ARU works by combining indicated airspeed and altitude in a complex way, so most of the time the needle will be between extreme positions. Drop tank and pylon lights, according to loadout. Make sure that the loadout lights illuminate in accordance with the external loads attached. Fuel gauge, check that it indicates actual fuel amount. The MiG-21 fuel system is composed of 6 fuselage tanks, 4 internal wing tanks, 2 external wing-mounted drop tanks of 490 liters each, and 1 external ventral drop tank of either 490 or 800 liters. Nominal fuel amounts. Tanks filled and no drop tanks, 2,750 liters. With 490 liters ventral tank, 3,250 liters. With 800 liters ventral tank, 3,500 liters. With 2 wing tanks, 3,750 liters. With 3 drop tanks, 4,200 liters. Warning light panel test button. Depress any one of the highlighted buttons and check that all lamps illuminate on every warning panel. We already checked them at mission start, so press spacebar to continue. Check the wheel brake system, with the nose wheel brake both engaged and disengaged. With the brake lever fully pressed, using the W key, the pressure should be within the limits of 9 to 10 kilograms per squared centimeter. Nose wheel brake, set to on, lever horizontal. Brake lever, hold the flight stick's brake lever fully pressed, and check that the brake pressure is still within the above limits. While keeping the brake lever pressed, push the left rudder pedal fully. The air pressure in the opposite wheel should drop to 0. Now repeat with the right rudder pedal. This tests the system's We will repeat the test, this time with nose wheel brake off, lever vertical. Brake lever, hold the flight stick's brake lever fully pressed, and check that the brake pressure is still within the above limits. While keeping the brake lever pressed, push the left rudder pedal fully. The air pressure in the opposite wheel should drop to 0. Repeat with the right rudder pedal. This completes the wheel brakes test. Press spacebar to continue. Navigational instruments, check. We will now check the DA200 combined indicator, the gyroscopic horizon, the KCM compass system, and the FDS flight direction system. Artificial horizon KPP. On the real aircraft we would use this knob to align the 0 mark of the roll scale. Unfortunately, it's not simulated yet. Euro FDS DA200 RDR AP signal switch, set to on. This powers up Euro number 2, used by the DA200 indicator, the NPP course indicator, the SAU autopilot and the radar. Euro FDS AP RDR signal switch, set to on. This powers up Euro number 1, used by the NPP, the SAU, the radar, and the KPP artificial horizon. Check that the red warning light on the caging button of the artificial horizon illuminates for a few seconds. The pitch scale of the instrument moves to its 0 level. FDS switch, set to on. This is the power switch for the NPP, course indicator system, and the FDS, flight director system. Artificial horizon, KPP, on the real aircraft, the KPP displays the correct pitch and bank correctly within 1.5 to 2 minutes of the red warning light extinguishing, but on DCS this time is much shorter. Press spacebar once the NPP has completed its initialization and its indication is steady. Set the Euro switch to its main Euro position, up. The KPP system uses data from 2 gyroscopes, main and auxiliary. Here we are selecting the main Euro for checking. The red warning light on the cage button of the KPP illuminates again, as the artificial horizon has changed over to the main Euro. It should go off within 15 seconds. The indicator should still show the correct pitch and bank. Now set the Euro switch to its auxiliary Euro position, down. The warning light on the cage button illuminates again, as the KPP has changed over to the auxiliary Euro. FDS slaving button, hold the FDS button for 3 to 4 seconds, to align the NPP course indicator with the magnetic compass. Good, the NPP should now indicate our current aircraft parking heading, 279 degrees. This completes the navigation instruments check. Press spacebar to continue. On this step we will perform an integrated check of the VHF-UHF radio, the ARC automatic radio compass, the RSBN navigation receiver, the RV1M radio altimeter, the MRP56P marker beacon receiver, and the SRZO2 identification friend-foe transponder, IFF. Begin by powering up each device. VHF-UHF radio, set to on, up. ARC navigation, set to on. Radar altimeter, set to on. RSBN navigation, on. SRZO, IFF, power switch, set to on. ATC switch, confirm that it is set to on, even if on DCS it serves no function. P07 VHF-UHF, to check communication, press the / key, or the PTT button on the HOTAS. The DCS communications menu should appear. Select F5, ATC, F1, Inches Airbase, F3, Request Startup. Press spacebar once air traffic control has given startup clearance. Press F12 to clear the menu. Check the operation of the squelch noise suppressor. By placing its switch at off, radio noise should be apparent. When it is turned on again, no noise should be heard. Leave it on. Adjust the audio selector switch on the radio panel to comp. This will allow you to hear the station Morse code identification. RSBN ARC selector switch, set to ARC. If the ground station signal can be received, the bearing to the ARC station will be shown on the NPP by its narrow needle. The Morse call sign of the station should also be heard. Press spacebar to continue. Leave the antenna switch at comp, and the radio switch at radio. This concludes the ARC check. RSBN, check. A bug on the simulation does not allow the RSBN to be powered with just ground electric power. It needs the engine generator online in order to function. So, we will have to postpone this check until after the engine has started. Press spacebar to continue. IFF transponder, check. To check the CP30 IFF equipment, make certain that the lights COD, codon and DEC illuminate within 2 to 3 minutes after turning on the IFF equipment. The ATC resp lamp should flicker as the IFF responds to ground interrogation signals, but this is not simulated on DCS. Press spacebar to continue. All power switches, except radio and PO750 start 1, off. We will power off all non-essential electronics. To reduce the load on the electric system during engine start. Nose cone switch, off. Arc power switch, set to off. Radar altimeter, off. RSBN power switch, set to off. FDS circuit breaker, off. SRZO, IFF, power switch, set to off. With the real aircraft, the standard procedure was to start the engine from an external power source, as we are doing on this mission, but if necessary, the aircraft battery could also be used for start, provided its capacity was not less than 40 ampere-hours. The same procedure is used for starting the engine, either using external power or the aircraft battery. Battery ground power switch, verify that it's on. Engine APU switch, confirm it's on. Afterburner switch, verify it's on. Fire extinguisher switch, check it's on. Engine starter switch, verify normal start is selected. Auxiliary 2-position nozzle control switch, verify it's off. Cone auto manual switch, verify it's at auto. Throttle, check that your HOTAS throttle is on its shut-off position. Press spacebar to continue. DC gen switch, on. PO750 converter number 1 switch, confirm it's on. Dispenser fuel tank pump switch, set to on. First fuel tank group pump switch, set to on. Throttle, move from stop to idle by clicking on its release latch. Engine starter button, depress 2 to 3 seconds, until the red engine start advisory lamp illuminates. Engine start light, verify it's on, indicating the engine startup sequence is active. EGT and oil pressure, while the engine starts, check the jet pipe temperature, should not exceed 700 degrees, and the oil pressure, which should be positive. After the engine has accelerated to idle RPM, the engine start light should extinguish in the warning panel. Idle RPM is reached when the low-pressure compressor speed, N1, has reached 35 to 40%, and the high-pressure turbine speed, N2, is at 50 to 55%. Verify that the jet pipe temperature does not exceed 420 degrees Celsius. Check the oil pressure is over 1 kilogram per squared centimeter. If the pressure is under 1.3 kilograms, the red oil light will illuminate. Press spacebar to continue. Having started the engine, confirm the AC gen and ground power switch is on, prior to disconnecting the ground power. Order the ground crew to switch off the ground power source. Press the / key, or the PTT button on the HOTAS. The communications menu will appear, select F11, parent menu, F8, ground crew, F2, ground electric power, F2, off.
Chief, turn off the
Press
ground
spacebar
power.
once the ground crew has disconnected the external power.
Copy. Ground power is now off.
Make sure the DC generator is online by the extinguishing of the DC gen advisory lamp, and by checking the voltmeter, which should show a voltage of 28 to 29 volts. Confirm that the AC generator is also online by the extinguishing of the AC gen advisory light. If the lamp is still lit, turn off the AC gen and external power switch and then turn it on again. Press spacebar to continue. As the aircraft is now generating electric power on its own, let's re-energize the aircraft systems. Inverter PO750 start number 2 switch, on, to enable the second DC inverter. Number 3 group fuel pump switch, on, to enable the fuel pumps of the third fuel tanks group. RWR switch, on, to activate the radar warning receiver. Nose cone, auxiliary hydraulic pump, and trim system switches, all on. Radio power switch, set to on, up. Arc power switch, on, to enable the non-directional beacon receiver. Rad alt power switch, on, to activate the radar altimeter. FDS switch, on, to enable the navigation systems. Gyro switch, set to gyro, to power and select the main gyroscope for navigation. Cam power switch, on, to enable the gun video camera. Note that when you powered the gun camera, the ground crew mounted it on the gun sight frame, partially obscuring the forward view. In real life it was only used for training, and on DCS it has no actual function. Feel free to unmount the camera by turning its power switch off. Press spacebar if you prefer to keep it mounted. SRZO power switch, on, to enable the IFF system. Flight rec power switch, on, to enable the SARP-12 flight data recorder. If you turn it on, it will record your flight parameters once per second. The data will be saved to disk once you exit the mission. The SARP is capable of storing 120 minutes of flight time, and you can find your SARP recordings in your Saved Games folder. The data can be graphed using Excel or utilities like JSARP or PYSARP. Press spacebar to continue. If the engine has not been tested or warmed up by the ground crew, you can run up the engine with the following procedure. First, make sure to enable the nose wheel brake by turning the highlighted lever to the on position, horizontal. Next, press the wheel brakes with pedals or the W key and hold them pressed during the whole test. Smoothly advance the throttle lever to obtain an M01 rotor speed of 88 to 90%. Warm up the engine at this speed for 1 minute, and check the oil pressure, which should be 3.5 to 4.5 kilograms per squared centimeter. The oil light should not illuminate. Check operation of the DC generator. The voltmeter should read 28 to 29 volts. Smoothly shift the throttle lever to military power, and keep the engine running at this power setting for 10 to 15 seconds. Be careful, do not activate the afterburner, as the wheel brakes will not be able to hold the plane still. Check the maximum RPM, jet pipe temperature, and oil pressure. Reduce the engine speed to idle, keep it there for 1 to 2 seconds and then move the throttle lever from idle to military power. Check any RPM over speed and any jet pipe over temperature. Leave the throttle at idle. The pilot of the real MiG-21 can also test the engine with afterburner on, but as the DCS simulation of this aircraft does not include wheel chocks, and the aircraft's wheel brakes are not able to hold the plane still, we will omit this test. Press spacebar to continue. We will now check those systems that require the engine running, because they need either full hydraulic or electric power. Press spacebar if you want to learn this section of the cold start, or press backspace to skip it. Check the trim actuator, operating the trim switch on the control stick backward and forward, using either your HOTAS or the left control plus T and left shift plus T keys. The control stick should follow the trim movements. Operate the trim until the trimming mechanism is set to neutral, which will be indicated by the trim neutral light illuminating on the center warning panel. We will now check the flight control surfaces of the aircraft. As the simulated ground crew can't check the flight surfaces from outside, we will instead use the DCS controls overlay. Activate the overlay by pressing right control plus enter. Next, smoothly deflect the control stick to its extreme positions, right, left, forward and back. The control stick should travel smoothly, and the trim neutral light should keep lit while the control. Good. Next, check that the rudder can be fully moved left and right. To finalize the check, close the controls overlay with right control plus enter. Check the functioning of the hydraulic system and hydraulic pumps, with the control stick centered. The gauge is a dual unit. The right side indicates main hydraulic system, the left side indicates the booster system. The pressure in the main system should be higher than 180 kilograms per squared centimeter, while in the booster system it should be higher than 185. Move the control stick diagonally several times as rapidly as possible. The pressure in the main hydraulic system should not drop below 175 kilograms, and in the booster system should not drop below 165. During this check, the yellow booster pressure or the hydraulic pressure lights may illuminate briefly on the warning panel. Press spacebar to continue. Extend the air brakes by manipulating the thumb switch on the throttle lever or with the C key. Extension of the air brakes should illuminate the air brakeout light on the landing gear and flaps indicator. Good. Now retract the air brakes. The light should go out as soon as they are retracted. Extend the flaps to the landing position. Once the flaps are down, confirm that the flaps out light comes on. Good. Now retract the flaps completely, and once they are up the light should go off on the landing gear and flaps position indicator. Once the check is over, leave the flaps extended to the takeoff position. Next, we will check the autopilot system of the MiG-21, more correctly known as the AFCS, Automatic Flight Control System, or SAU by its Russian acronym. Switch on the autopilot circuit breaker and turn on the AP pitch power switch. The AFCS has 4 modes: automatic, stabilization, recovery and directional. To check the latter mode, ensure that the flight directional compass system is properly slaved by checking that the FDS switch is on the nav position, and confirm that the compass heading on the NPP is correct for our ground position. The highlighted AP stabilization button light activates the stabilization autopilot mode, which dampens aircraft vibrations and stabilizes current aircraft position. Additionally, the SAU will try to stabilize your heading and pitch if your bank is small, less than 10 degrees, or your bank and pitch if your current bank is greater than 10 degrees. Engage the AFCS in the stabilization mode and check its engagement. The recovery SAU mode will try to recover the aircraft from any attitude to a level flight. Enable this mode with the highlighted button on the flight stick and check its engagement. 1.5 seconds afterwards, the control stick may start moving smoothly forward and/or backward. Depress the SAU autopilot off button on the control stick and check the AFCS for disengagement. Shift the control stick to the neutral position by manipulating the pilot's trim thumb switch. This completes the AFCS check. Press spacebar to continue. RSBN check. To check the RSBN navigation equipment for serviceability, proceed as follows. Make sure that the RSBN power switch on the right cockpit wall is on. Also, check that the RSBN arc switch selector is on its RSBN position, up. The RSBN is fitted with a self-test device that generates a synthetic test signal. Press and hold the highlighted RSBN test button. The thin needle on the NPP should point to azimuth 177 degrees, while the RSBN distance indicator should show 199 kilometers. Release the button to finish the test. Select the RSBN and PMRG channels. Use the RSBN volume knob to adjust the volume of the identification Morse code received from the RSBN station. If the selected RSBN station is near, the azimuth and distance correction lights will illuminate, and on the NPP the thin needle will point in the direction of the station. The distance indicator will show the actual distance to the beacon, in kilometers. This completes the check. Press spacebar to continue. We will next check the ASPPDF optical gun sight. This check should actually be done before starting the engine, but the DCS MiG-21 has a bug that prevents the gun sight from operating with ground power alone. The switches for battery, AC generator, and PO750 start number 2 inverter should be already on. Now, turn on the sight switch to energize the gun sight. Set the GN LNC switch to GN. This switch adjusts the sight aiming mode for guns when up, or missiles and rockets when down. Confirm the air-ground switch is set to air. The ground mode is used exclusively for dropping bombs, while air mode is used for aerial targets. Set the auto-man switch to its manual position. Auto mode automatically sets the angular scale correction for you, based on the currently selected weapon. Gun range distance setting is automatically set for 300 meters. Man mode allows you to manually set the sight distance range and angular scale correction. For the sight check, we will use this mode to be able to adjust all sight controls. Set the MSL gyro lever to the gyro position. MSL renders a pipper cage to the center. This mode is used against maneuvering targets, which is a situation where you are likely to use air-to-air missiles. In that case, the fixed net should be used for targeting, because in this situation the pipper intercept angles could potentially go beyond the 7 degrees limit of the sight reflection glass. Gyro is used for non-maneuvering targets, flying at less than 3G. The pipper is not stable, jumps around uncaged, and can be used for targeting. Set the SB switch to the S position. The bombardment, B, position is for dropping bombs. The shooting, S, position is for firing the gun. Turn on the sight reticle, also called pipper, with the switch on the left side of the sight, and adjust its brightness with the adjacent knob. Turn on the fixed net, with the switch on the bottom of the sight, and adjust its brightness with the adjacent knob. This knob adjusts the backlighting of the range scales at the top of the sight, which show current distance to the target. The left side of the scales represents minimum range, the right side being maximum range. 4 scales are provided, from top to bottom. The topmost scale indicates diameter of the pipper in milliradians, the second from the top indicates short distances, 400 to 2000 meters, and is used for air-to-air gun attacks. The next scale indicates distance for air-to-air missiles, 1 to 9 kilometers. The bottommost scale indicates distance for air-to-ground rockets and guns, 400 to 2000 meters. Turn the span ring, mils, knob to make sure that the diameter of the reticle diamond ring changes in response to rotating the knob. This knob is used to set up the target size in meters. Its scale corresponds with the target size in meters when in automatic air-to-air gun mode. In all other cases, the target size is shown in the small red window to its right. In preparation for the next step, please set a span of 18 meters on the left dial. Twist the handle on the throttle lever and check that the sight reticle deflects along the vertical, that it changes diameter at closer distances, and that the range pointer moves on the scales, following the handle twisting movement. Check also for illumination of the launch authorized and break-off lights. On the top left of the sight is the launch authorized red light, which should illuminate when the target is within the weapon range. On the top right is the break-off red light, which illuminates at short ranges, when a brake maneuver is needed, both for airborne and ground targets. Press spacebar to continue. Make certain that the sight range-finding diamond ring gets enlarged and the break-off light illuminates, as the range is set closer. When the throttle handle reaches its minimum range, the range reticle will suddenly grow, denoting that the sight has been changed over to its 300-meter fixed range mode. Place the air G&D switch in the ground position. Rotate the throttle lever handle to make certain that the launch light illuminates when at a range of 1,950 meters. The break-off light illuminates at a range of 1,600, for the case of launching Type C-24 rockets, and 1,200 meters for the case of launching Type C-5 rockets and firing the gun. Set the SB switch in the B position, and check that moving the angles knob causes the reticle to move downward as the angle increases. On the real MiG-21, once the SB and gun LNC switches are set back to their air-to-air positions, S and gun respectively, the angle scale would return to 0 automatically and the sight reticle would return to its centered position, but this is not simulated yet, so you will have to reset the angles knob manually. When through with the sight check, set the gyro MSL switch to its MSL position and place all other switches to the positions required for performing the current mission. Press spacebar to finish the sight check. Congratulations, you have completed the cold start training for the MiG-21. We hope that you have enjoyed the additional information that we have provided about the different systems of this aircraft. On our next training mission, we will learn to taxi, take off, and climb to cruise on the MiG-21. You can now press spacebar to exit the mission.